Okay, in this video we'll be going over some typical questions that you can get in level 3, at least, for naming and drawing compounds. So without further ado, let's just get straight into it. Because I want to finish this fast, I will be doing the skeleton structures. Okay, so let's just go over skeleton structures. Okay, you cannot do skeleton structures in NCEA, but it is very useful in university, and if you're not exposed to it right now, it can be a bit confusing sometimes to try and draw these out. But I really do encourage you to try both ways of drawing compounds, both the structural way and then also the way that I will be doing today. So just recall that each of these, okay, so each of the corners that you see, they are carbons, okay? So corners, and each of the ends are carbons. And ends of lines are carbons, okay? And then this part here, of course, this signifies the bond. So for example, if you have a double bond, it would look like this with another line. And if you had a triple bond, okay, it would look like that. And then also just remember that there is hydrogens that exist, but we don't draw them in stick structures because it will look really messy. So for example, you can imagine that in this one, this is a carbon, so that's a C, and there's 3 hydrogens here, okay, because this carbon, remember, carbon likes to bond to 4, or likes to bond 4 times, so we got 1, 2, 3, and then the 4. We don't show that, but obviously it's there, okay? So yeah. Where I can, I will draw the complete structures, and if the molecule is too big, then I'll draw the skeleton structure, okay? I'll see how I go. Okay, so let's just get straight into it. So we got drawing. Let's do this. We have butanoic acid. So maybe if I get tired, I will draw the skeletal structure. So we got 1, 2, 3, 4. Oic acid is in carboxylic acid. And we got carbon number 1, carbon number 2. So we got a methyl here, CH3. Fill in the hydrogens. And yeah, that should be done. Let's move on to the next drawing one, actually, because I do like drawing. I'll give you an example of the skeletal. So this one over here, pent means 5 carbons. When you see oil chloride, that's your acid chloride. And remember, an acid chloride is a carboxylic acid derivative, so it looks like a carboxylic acid, but this here, that's replaced with a Cl, so it looks like that. Okay, so let's go 5, 2, 3, 4. Yep, come in. What up? I'm doing a video. So sorry. Anyways, so let's do 5. I'll do the skeletal structure. 2, 3, 4, 5. Actually, I don't want to confuse you. Let's go 2, 3, 4, 5. Let's go double bond oxygen, Cl, okay. And then we got 3 bromos. If we go 1, 2, 3, got a Cl here, okay. So hopefully you can see that that's the correct one. If you wanted to do it, if you wanted to check it, it would be pent 1, 2, 3, 4, 5. We would have a double bond O and a Cl. And then on carbon number 3, so we've got 1, 2, 3. Over here, we would have a chloro. Sorry, not a chloro. We would have a bromo. Because it's bromo. My bad. Bromo. Okay. Yep. And then you would just fill in the hydrogens. Okay, so yeah, cool. Let's go over this one over here. So in terms of naming, so we got what's the longest chain? We got 1, 2, 3, 4, 5, 6. So we got pent. Okay. Let me just check something. One moment. Yep, so we got pent. Okay. We've got pent, then we got to identify the functional group. This is clearly the functional group here. Hopefully you recognize that it is a ketone. This is a ketone because we just have a C double bond O in the middle of a carbon chain. So that would be pent 3. Why is it drawn to the side? We have pent 3 ion. Okay. And then the next one, hopefully you can see that this is an ester because we have this functional group here. And we talked about in class where we can kind of view this portion here as the alcohol, as like a methanol. We can view it as like a methanol, okay, that like got bonded here and this hydrogen got ejected out. But in any case, naming esters are quite interesting. Heaps of people get it wrong. And the way you usually name it is that the alcohol component, okay, so this part here, we consider that as naming, let's say, somewhat like a substituent. So you would write this one as methyl, okay, and then you would go 1, 2, 3, 4. So 4, we would say bute and noate. So bute means 4, and noate, that's the suffix for a ester suffix. Okay. Let's go on to the next one. So let's draw this propanamide. So we got 2, 3. We got an amide, not an amine. So it will look like this. And on the third carbon, we have chlorine. So we've got 1, 2, 3. Over here, chlorine. Okay, always starting with the functional group. Next one, let's name this. We got 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5. We have 2 versus 4, so we want the lowest number. So we're going to rub out that orange one because 2 is the lowest one. And so we're going to go pent, and then we're gonna go to own. All right, let's do this one. We have another ester. We have this as the alcohol component, so we would say this is methyl. And then we've got 1, 2, 3, so that's prop. So we're gonna go propanoate, right? And then we got 2-methyl-butanol, sorry, butanol. And so we got but, which means we got 4 carbons, 2, 3, 4. Got a NL, which means we got a double bond oxygen and an H. Okay, and then we got on the second carbon a methyl group, so we got 1, 2. So over here we have a methyl group. Yeah, so I can just leave it as a line like that. Okay, if you're not convinced, it looks something like this. I'm not going to draw the hydrogens in other than the aldehyde component. Okay, and you can fill in the hydrogen over there. That's what it would look like. Next one. What do we have here? We have the functional group of an aldehyde and a haloalkane. We already discussed this. Haloalkanes never take priority. So the main component of this one, or the main functional group, is aldehyde, which has the suffix al. Okay, so let's count the longest chain. Starting, it's always good habit to start with the functional group. 1, 2, 3, 4, 5. Okay, so that would be pentanal. Okay, and then we can say 4 chloro. Okay, because we have a chlorine on the 4th carbon if we start from the functional group and we count that way. Okay, let's go to the next one. I want to rub out these numbers. Okay, they're confusing me. Right, next one, ethyl hexanoate. So we are drawing an ester. Okay, so we know that this ethyl means that it is like the alcohol component of the carboxylic acid. So I'm gonna go, my pen has just died on me. I'm gonna draw with my finger. Actually, I don't butcher it. Okay, definitely I will be doing the stick structure then, in this case. So this ethyl would be oxygen. Let's do it over here. So we got oxygen. That's an oxygen, by the way. We got 1, 2. This oxygen is bonded to a carbon, which also has a double bond oxygen. That's an oxygen. Okay. And we got hex. So we got that counts as 1 carbon. So this one counts as 1 carbon. Okay. Let's just move my arrow. That's 1, 2, 3, 4, 5, 6. And that should be your ethyl ethanoate or ethyl hexanoate. Okay, so we have 1, 2. We got 1, 2, 3, 4, 5, 6. Sorry guys, I'm doing this with my finger. Okay. Okay, next one. This one, hopefully you can see that this is an amide. This is an amide. Wait. Okay, that's not working, is it? See if the pen wants to work again. Ooh. So this is an amide, this group here. Amide. So let's go 1, 2, 3, 4. So we know that that's butane amide. And we know that there's a methyl group branching off at carbon number 3. So methyl. Okay. Let's move on to the next one. You have a go. See, make sure you pause every single time. So 1, 2, 3, 4. So we have bute. We have a this functional group here and this functional group, but we don't consider that as a functional group. Never. Haloalkanes is never a functional group. Okay. So the priority is this acid chloride. And remember that has anoyl chloride as their suffix, so it will be butanoyl chloride. And we would have 1, 2, 3. So we would say 3 dash chloro butanoyl chloride. Let's do this one. This functional group is a ketone because we have a C double bond O in between two carbons. Okay, so that one would be 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5. 2 versus 4, obviously 2 wins because 2 is the lowest number, so we're gonna ignore the top numbering assignment method, and so we're gonna say pent 2 own. Okay. Next one, hexanal. So that's that would be hex would be 6 carbons. Hopefully you're getting used to it. So 2, 3, 4, 5, 6. And on the fourth, sorry, hexanal means we got a double bond oxygen and an H. And then we got 4 methyl. So if we go 1, 2, 3, 4, we have a methyl group popping out over here. Okay. If you're confused, 5, 6, double bond oxygen, H, 1, 2, 3, 4. We got CH3, and the rest is hydrogens. Okay. And then propanamide, we got 3, because propan means 3, so we got 2, 3, double bond oxygen, NH2, that should be fine. If you're lost, it looks like this. Okay, and fill in your hydrogens as well. Okay, next one, prop. That means 3 carbons. We got 2, 3. Anoyl chloride means not carboxylic acid, it means acyl chloride, and that should be done. So in other words, it is this one. If you're lost on the skeletal structure. So I just realized we need to add the infix. So wherever we did this one, it should be like pentan. My bad. So I'll go and fix that up. Where else here? Pentan 2 own, not pent 2 own, pentan. I always get that mixed up. Pentan 2 own. That's what I was looking for before. I didn't see it, obviously. This is pentan 3 own. This one would be pentan 3 own. And yeah, that's it. Cool. Hopefully I got all of them. Don't worry, 1, 2, yeah. Okay. Let's carry on. Okay. So pin 10 to own. Pint means 5. So we got 2, 3, 4, 5. We got a double bond on an oxygen on the second one. And 3. So we got 1, 2, 3. So we got a bromo here. All right. If you're lost on that because this is upside down, it looks like this. Pint. You can do it like this. Bromo. Okay. Or remember, you can also do it like this. VR. And it also doesn't matter, like, if your bond is pointing down or if this bromine is going up. Doesn't matter. Okay. Let's carry on. This one, I'll draw over here. But means 4, so 2, 3, 4. And we have a double bond, O and an H. And then we also have 2 methyl, so that's carbon number 1. This is carbon number 2, so we've got a methyl. I decided to draw my aldehyde on the left-hand side, just because I wanted to. Okay, next one. 1, 2, 3, 4. So you know that's but. That's a beauty. That one is ketone because we have a double bond between 2 carbons. So we know that's on carbon number 2. Hopefully you can see. 1, 2, 3, 4 versus 1, 2, 3, 4. We get 2 and 3 for both the cases, but remember we want the functional group to have the lowest one first. Okay, and everything is with respect to that. So we go butane 2 earn, and then we can go 3 chloro, butane 2 earn. Okay, propanamide 2, 3 double bond O NH2. Okay, I think we've done this one before. Okay, yeah, all right. And then the other one, let's look at this. Now they drew the ester upside down and backwards just to confuse you, but that's the alcohol. Okay, so remember that alcohol component is counted as like a substituent. If you were to say it's not really a substituent, but yeah. So we would go, that's 1 carbon, so we would say methyl. And then we'll count 1, 2, 3, 4. So we would go butanoate. Okay, and then the last one, let's go 1, 2, 3. We got 3 hydroxy propanal. This one, propanamide, we just did that. If you're lost again, they have done it like 3 times. Wait, that's a 2, by the way. And this one, 1, 2, 3, 4, 5 versus. Yep, that's all good. We go. That would be 1, 2, 3, 4. 4 methyl. 4 methyl. Pentane 2 own. Okay, so I hope that helps. That was a long one. We went through literally pretty much every single past paper that they did, minus a few because we've done it already in class. So goes to show how fun these can be, bit tedious but fun to work out when you get the hang of it. Okay, so I hope that helped, and I'll see you in the next video.